Okay, so this is the first video going through review of the projectile motion for the upcoming projectile motion test. The answers are given on each of the sheets, so I'm just going to go through how to solve each problem, and hopefully this will clarify for you. So let's just jump right into it. So we have an object moving through air. We have 3 points, A, B, C. They want to know about the speeds. And we could just as well ask about the accelerations. The idea is the horizontal speed stays constant throughout, but the vertical speed changes. So if initially the actual speed is this vector here, so there's a component, and then we see at the top there is no more vertical component. So the speed A has to be greater than B. And then when we get to C, if we look at C as the same level of A, then it has the same speed downward by symmetry and the same horizontal. So we're going to have A equals C, and B is less than that. So B is the least, and that. If we ask about the acceleration of the ball at point C, it's always down at G. In fact, it's G here, it's G here, so it is down, and that's it. In fact, in every place, it's going to be down. So don't confuse speed with acceleration, which is often done in that kind of problem. So it's always accelerating in the vertical direction, never in the horizontal direction. That's one of the key facts about projectile motion. Okay, let's go to now some of the computation problems. These should all be done using VTEX. So here we have, and it's not stated directly in it, thrown off the ground, this must be projected upward because they give you a horizontal velocity of 15 and they give you a vertical velocity of 6. So imagine you're doing a VTEX table. It takes 3 seconds, so there's a time to reach the ground. Okay, what is the height? So the height screams we want to do vertical. And in the vertical, we use the 6. That's an important one. That's our V naught. Our V naught is 6. Our time in the air is 3, so we can use that. And we know that acceleration is negative 9.8, so we can solve for delta y. So we can say delta y, all right, is equal to V naught yt. Right, I'm just going to put in a number. V naught is 6. It's the key thing is it's the vertical velocity times the time 3 minus 1/2. I'm just going to call G10 here times 3 squared, and 3 squared is 9. Okay, so 10 times 9 is 90. Half of that's 45. 18 minus 45 gives us 27. Now this is a negative 27. That just means we're below where we started, but that also corresponds to a height, because that's what they're asking. What is the height? And that is 27 meters. Okay, next we got another problem. The key thing here you want to recognize right away when you do these problems is it at an angle or is it horizontal? So horizontal, we have information. So we have a height, that's y. We had a level ground with velocity, there's v naught in the x direction. And the negative blah, blah, blah. Where does the object land? They want x. And this is a very familiar problem. We've done this before where you're given height and you're given launch speed, we got to find x. And this requires both the horizontal and vertical information. Again, I don't have space really to do VTEX, but since we're looking for an x, and the general equation for how far we travel is vxt plus 1/2 ax, a sub x, right, the subscript. And you should be doing a VTEX on this. You should be looking at what you did, because if you didn't, you're really not trying here. This is 0. So it's just Vx times t. So we have the Vx, that's the 125, but we don't have the time in the air. We have to figure that out based on the fact that it's at a certain height, okay? This height right here is 125. So if we look at, I'm sorry, this is not 125. The speed is not 125. I was careless because it's all covered up. It's 15. And so in the height column, if you look on your VTEX, you know the initial velocity v naught y is 0. Okay, do not put into the 15 meters per second. We know that a is g, and we know delta y is technically 125. So long story short is I can use this equation again for the y, and that turns out to be that delta y equals 1/2 gt squared. So we know from before, and you should be able to look this up in your notes, 2 delta y over g. Okay, so if I do 2 times 125, I get 250. 250 divided by 10 is 25. Square root of 25 is 5. So the time in the air is 5. 5 times 15 gives us 75 meters. So two-step problem in a multiple choice. Because we've done enough, you should be able to do that fairly routinely. All right, next one. We got a projectile with an initial speed of v and an angle. So this is angled above the horizon. What time does the projectile hit the ground? Okay, so you got to do the two columns, but in this one we can focus on one. Why does it hit the ground in a certain time? Because of gravity. So that tells us we want to do the vertical column. So I'm just going to focus on the vertical column here because that's all that's relevant. Do we know initial speed? Yes. It is v, but we need v in the y direction, so that's got to be v sine theta. All right, that's the key thing there. Yes, it is launched at initial speed v, but since we're looking at the y column, we need to sine theta in there. We know a is g, we're looking for t, right? And what is important here, and there's two ways you can do this. I'm going to do it for the full flight. If we look at the full flight, then we know that delta y is 0. You could alternatively do it for half the flight. And in that case, you don't know what y is, but you do know that vy in the final velocity at the top here is 0, and then double your answer. So I prefer this method here. And so what I can say is the equation I want to use, and again I'm struggling for space here, is I can say if I want that 0, that's my change in y, equals v sine theta, right? Minus v sine theta t minus 1/2 gt squared. All right, now because this is 0 right there, and I'll let you show algebraic, this t cancels out and one of these t's cancel out. Okay, so if I solve for it, I've got negative v sine theta. I subtract it to the other side. I got to multiply it by 2 to get rid of the half. And then I divide by g, and there's my answer. Okay. The other thing you could do here, if you don't want to use this, is you know that the final speed is the negative of v sine theta. So you could use a different equation and end up the same result. The point is, you want to use the y column. There are 3 different ways you could do it. 2 ways doing the half or the full trajectory. Maybe a simpler way is just doing half the trajectory and then doubling your answer. All right, moving on. So we have a proportions problem, and they're basically saying the height is doubled, and we want distance. And what we can do is go back to this problem here, okay? Because it's the same problem. This is a little bit more difficult in that you got to combine your time equation and your v equations. The derivation we've done 2 or 3 times already, and so we're testing, do you remember how to do that? So basically we want range, that's an x. X, we know that's vx, because it's v naught t. Because it's launched horizontally, there's no sine or cosine. The time in the air we derived earlier was equal to twice the height, and I'm going to call it delta y over g square root. So if we combine both equations, we have the x equals v times square root of 2 delta y all over g. And what we can see here is that, again, I apologize for that, I'm going to write up here, that x is proportional to the square root of delta y. Those are the things we're interested in. Height is delta y, x is that, and we see there's a square root relationship. So long story short, if we double the y, and that's proportional to, or that's going to be equal to, what do we do to the y? We made it twice the value, so it's square root. So it's going to be square root of 2 times the distance. So doubling height doesn't double the distance, as you might think off the top of your head. It's actually square root of 2 because the time goes by the square root of the height change. All right, conceptual problem, baseball player horizontal, which best describes the motion after it's thrown? Vertical speed can't remain the same because it's accelerating, so I can throw out A. Vertical speed remains the same, we can throw that one out. Vertical speed increases, absolutely, so it's either C or D. What do you know about the horizontal speed? It's constant, so it has to be that. So again, that fact that vertically we are Accelerating horizontally, vertically we are accelerating, and horizontally where constant comes into play here. All right, let's move on. All right, a little derivation here. So we have an object roll off the table, it lands d away. From the edge table, what is the initial horizontal velocity? Okay, so horizontal velocity is constant, and that we know then is simply x divided by t, right? If we already knew x is vxt, right? Vx is x divided by t. Well, we're almost done. We know it's, and so in this case, that's d. D is the distance, right? So it's got to be, well, it can't be this one because it's not divided by time. It can't be this one because d is an denominator. So you can see how I'm using, very simply, how I can eliminate it. Now the question is, what's the time in the air? Oh, once again, from the previous problem, the time in the air is based on the height, and that's going to be 2h over g. So this is going to be d divided by radical 2h over g, and that looks like letter A. So, wow, this might look like an intimidating problem. It's actually pretty straightforward. Okay, so let's look at the next sheet in the few minutes I have remaining. Let's see if I can bring that up. Okay, so some IB problems to just kind of supplement what we had here. Let me see. Nope, I wanted this. All right, wrong one. Okay, so we got air resistance is which one of the following best takes the path of falls back to earth? Air resistance is negligible. All right. All right. I'm not sure why as it rises and falls back to earth. Air resistance is. Yeah, that would be this one right here. I'm not sure why I put that because that's pretty easy. Maybe we want to contrast that. Yeah, I think I got this right. If it was non-negligible, then it would look, it's really hard to tell the difference between A and B. So if it was non-negligible, it would be maybe something like that. So yeah, I'm not quite sure what I'm looking for in that last one. Okay. I think I meant it was air resistance is not negligible, so if it is that one, it would be A. All right, I'm going to move on. Okay, so which one of the following is correct? We have an object rolling off. It's going to do something like this, and then we have a second heavier ball. Well, we learned mass doesn't matter. Okay, so the time it takes to land is independent of mass, and the distance it travels is also going to be independent of mass. So it's going to be letter A.